Hello students, today we are going to see the review of the vector calculus. So the first thing what we are going to is see the del operator followed by gradient, after that divergence, and then it comes the curve. So gradient, it is the action of del vector on the scalar field. In the last video we have seen there are four types of multiplication. One is scalar multiplication, another is scalar and vector multiplication, then comes vector and vector class multiplication, which is again classified into dot product and cross product. So here it is a gradient, it is nothing but a vector is multiplied within a scalar field. Here the vector used is the del vector, and the scalar would be any scalar field can be, but vector is only one vector, that is the del vector. So what is del? So gradient of is a vector operator denoted by the inverted triangle commonly called as del or nabla. It is used on the real function of three variables, maybe two variables or three variables or single variables. So we can operate this del vector on any dimension. This del vector is known as gradient operator. Gradient operator means this del vector has to be multiplied with a scalar field. So in this gradient operation can be done in three coordinate system: Cartesian or cylindrical or spherical coordinate system. In Cartesian coordinate system, the gradient will be a function of x comma y comma z, which is given by grade f, that means grade, this is del vector, and f is a scalar vector. So del into f, and del is usually represented by, del is always represented by del is equal to d by dx of ax vector, d by dy of ay vector plus d by dz of az vector. It can also be represented as del dou by dou x with ax vector, dou by ay vector plus dou by dou z in z. When you operate this del vector on the function f, we get ax into dou f by dou x, ay into dou f by dou y plus az into dou f by dou z vector. We can express this vector in cylindrical as well as in spherical coordinates. Instead of ax, ay and az, you get, so they say component dou by dou rho, dou, you read this as dou by rho dou pi plus dou rho by dou z. For spherical coordinates, and this is radius dou r, this one r d theta, and this one r sine theta into dou pi. So definition. So in this diagram here, del is the vector, pi is the scalar. So pi scalar field is a differentiable one. If it is not differentiable, it is a constant, then in the scalar will become 0. So pi of x is equal to y. This is a pi is a scalar field which is going to vary with x, y, z. The total function will be a constant. So if you find the gradient vector, it will point in a direction like this. So in other words, we can say on finding the gradient, we are getting a vector which has magnitude as well as direction. The direction of this gradient vector will be pointing the maximum change in pi. Okay, did you understand that the direction of this gradient vector will point the direction, and where there is a maximum change in the rate, change in its magnitude. So let us see the significance of gradient vector. The direction of grade f is the orientation in which direction derivative has the largest value, and the magnitude of grade f is the value of that directional derivative. So direction derivative has the magnitude, large magnitude, because it will point a direction which has largest sign. Furthermore, if the gradient is not equal to 0, then the gradient is perpendicular to the level curve z equal to f of x comma y. Okay, this gradient vector will be at 90 degrees if the gradient is not equal to 0. So gradient is a vector in the direction of most rapid change of t, and its magnitude is equal to the rate of change. The result will be a vector quantity, as a maximum rate of change of scalar quantity will have the direction. So can you understand? Because the field is a scalar, there is no direction. It is all pointing in our direction, no direction. If you apply the gradient, it is finding a direction where there is a maximum. That means it is finding a direction, means you are getting a directional quantity. So you can say the gradient operator is a vector field. So for a better understanding, let us say an example. Think of skiing down a mountain. You want to descend as quickly as possible. You sky the path that follows the negative of the maximum rate of change in elevation. எங்கே நல்லா ஸ்லோப்பிங் ஜாஸ்தியாக இருக்கும் அந்த பாத் அண்ட் we will use to prefer. So that would correspond to the negative of the gradient. So there are some properties for the gradient operator. Del of u plus v will be equal to gradient operation on addition of two vectors, addition of two scalar field will be equal to gradient operator single scalar field del u plus del v. Here the product of scalar field, then you can say u into del v plus v into like a differentiation. If del into v power n means n into del v to the power n minus 1 for any number of n. The projection of del v in the direction of unit vector a is del v dot a, and is called the directional derivative of v along a. This is the rate of change of v in the direction of a. So if you multiply unit vector with gradient operator, gradient vector, see here v is a scalar field. See, take this term. V is the scalar field, del v is the gradient. If you want to get the direction derivative, you multiply this del v with unit vector. If you multiply this with unit vector, the particular product will become directional. The magnitude of this vector gives the maximum rate of change of scalar field and directed towards maximum change occurs. We like to operate this gradient operator on our electrical field. So electric field intensity E at any point will give by E is equal to minus grade V, which is the negative gradient of the potential. V is the potential, E is the electric field. Negative sign implies the direction of the electric field intensity will be in opposite direction to the potential. You can see an example here. Consider the gravitational potential on the surface of the earth. So here G is the gravitational potential, and if you write the gravity constant, earth constant, so we want to find the potential due to the gravity. So V is a function of G into Z, and here Z is the height. If you are lying on the surface of the earth, we have the large gravity of center of gravity. If he goes on rising to the altitude, height rise ஆக நமக்குடைய gravitation pulling symbol குறைஞ்சிட்டு. So V of Z equal to minus G. If you want to find the del V, so del V is equal to, here the function will be, we have to integrate, here the variable is Z. So del V will vary the Z. So if you write minus G, you differentiate with respect to Z, we get minus G dou Z by dou Z. If you have the differentiation, you get minus G. The corresponding vector will be, since it is an Z, A is a direction. So find the gradient of V at 1 minus 1 to the, they given the specify the point, and the V scalar field equation also given. So del V equal to, see here, you vary a scalar, you differentiate a scalar field with respect to, first you differentiate the hot things. So here you get 2xy. So here 2xy. For this bracket y square, for this z square. So all the three is obtained by varying with respect to x. The corresponding vector will be x cap. So then comes the y variation. So x square plus 2xy plus 0. So comes the second one. And the third one, with respect to z, we have to do 0, 0. Here you get 2xz. So now you apply the point value 1 minus 1 2. You get the gradient vector as del v of 1 minus 1 2 equal to 3x minus, so 1, substitute this value, you get 3x minus y plus minus y vector plus 4z vector. So this is an exercise. Let us see the gate question. Find the gradient of the scalar field u e power minus z sin 2x cos hy. So you have to differentiate with respect to x. Write the unit vector along this fashion. Differentiate this expression with respect to y. Then write unit expression. Differentiate this equation with respect to with respect to z. Then you find the unit vector. So what you have to do first, let us differentiate with respect to x. So with respect to x, if you differentiate, this is the only term. So you get 2 times cos 2x. So 2 into cos 2x. Remaining term remains the constant. So e power minus z cos hy. Unit vector is ax. The second term you have to differentiate with respect to y. That means cos hy alone present. This will be differentiated as sin hy. Remaining two terms are lying same thing. And with respect to z, if you want to do this one, so e power minus z we can write as minus z into e power minus z. So you are getting this term. So this one, so all the three parameters should be applied with the vectors. So if you see vector, the scalar field, there is no vector. If you find del v, you have to incorporate ax, ay and az, which is a vector. So this is a scalar field, del v is a vector field. So likewise you go for the second one, rho square is cos 2 pi. Actually it is for cylindrical coordinates. So for cylindrical coordinates I have already given the expression. Though first one you differentiate with respect to dou pi, second one you have to differentiate with respect to dou pi, and third one you have to differentiate with dou z. So first one rho, so 2 rho is that cos 2 pi, 2 rho is cos 2 pi, a rho vector. With respect to pi, means already 1 by rho is here, so you keep the 1 by rho. With respect to pi, if you want to differentiate, cos 2 pi will be changed into minus sin 2 pi. For 2 pi you get 2, minus 2 into rho square by rho. 1 rho get cancelled, so you are getting one single rho is a sin 2 pi a rho plus rho square. And with respect to z, you get rho square into cos 2 pi a z vector. So the last one will be for spherical coordinates. Though r into d theta, r sin theta dou pi. With respect to r, if you differentiate 10 sin square theta cos pi ar vector, then with respect to theta means sin theta is going to multiply. So what you get is 10r, 1 by r should be keep as such. We get sin square theta means 2 sin theta. Then for sin theta, the a theta. Then for pi, with respect to pi, if we do means cos pi will change into minus pi, minus sin pi. So likewise you have to do the problems. As a revision exercise, I have given a quiz question. Find the gradient for the scalar field. The scalar field is given by xy square minus 2yz. We find out the answer and mark your answer and send me this answer. Please, the answer what you got in my mobile, I'll mark the attendance for you. This is a homework. You have to find the gradient for the following three vector fields. Now the three fields are Cartesian fields. The next comes the action of del vector on the vector field. So the previous gradient is the action of vector on del vector on scalar field. So still two more is pending, action of del vector on vector field. it has to one is dot product and another is the cross product. So let us see these action of del vector and vector field in the next class. I think you have understand. If any doubt, you can query the, you can ask the doubt. So thank you.